the client for our Hello World RESTful application. Hey guys, how's it going? Start up your IDE. We will code a JAX-RS client now. We are starting with a normal main method, you all know that, and we will do the necessary code to call our JAX-RS Hello World server. The first thing you need to use JAX-RS on a client is to create a JAX-RS client, which is rather easy. There's a class called client builder. For that, you can say new client and you have a client. This is the most easy way. There are more methods you can use. We will use them in later episodes. And using this client, we will invoke our get method on the server. So let's see how that works. Let's store the client. By the way, you should never recreate a client often. If you're doing that, you will end up with a lot of garbage collection and a lot of time squandered just for loading class, getting rid of it, loading class, getting rid of it. There's a second reason you will see later, which is HTTP 1.1. We also should take care to always close the client when we're done using it. Certainly in this small main method, there is no use from that, but just for safety, we're writing the correct code, so you will know what I mean. And the reason is that if you have a longer code, you will be sure that all resources are closed right here in line 13 and not sometime later, or possibly never. So now let's do the HTTP call. The first thing you need is a target. So what is target? It's actually the endpoint of your server. And to create a target, you need an URI. So you could certainly give the URI directly. I'm using another JAX-RS goodie, which is the JAX-RS URI builder. And the URI builder is good for creating complex URIs. Certainly in this small program, this does not make sense, but I just want to show you the class so you know there is some help for you. And the URI builder has a static method which is called from URI, and you give the first part. We could also give the port. I just want to demonstrate the methods the URI builder has, so I'm explicitly giving it a path. We can also set the port number and so on. So it's a complete builder for URIs. In our simple example, we can get rid of that method because we are running on the root path, which is the default. And we are running on a static port 33333 I have chosen. And the last part is to build the URI. We don't have any parameters, so just keep it empty. The result is in the URI. And we pass the URI here, certainly. So now we have a target, and with that target we do our invocations. So we need to tell the client what actually method we want to invocate. So we start building a request. And invoke the get method. While this actually would invoke the get method, we want to process the entity we get back from the method. So what data type is this entity? We know for sure that it's a string. So in our small example, we can simply write string class, and the client will automatically invoke the correct parser to create a pure string from the entity. Actually, this is much more sophisticated than you think. You could pass more complex types, so it would invoke the parser to create complex Java class instances from the actual content. In our example, it's pretty simple, like this. And in the end, we want to print it on the screen. And that should be it. So let's run it. And there it is. It says, hello world. That's pretty great. So is that everything we need? No, certainly not. How should the client know what product you have chosen? In an earlier episode, I told you that JAX-RS is just a framework which is only API. So you need an implementation. And I have not shown you the implementation you actually need. So this is the next step. I did it up front, so that's why it's working. Certainly you need to do that too. As always, I'm using Maven, so let's look into the POM file of the project. I'm skipping the parts we already discussed in earlier episodes because this has nothing to do with the client but solely with the server. The client actually is just these two dependencies, which in my case is Jersey core and in particular the Jersey client. And as Jersey is a framework itself, you can choose the actual HTTP layer you want to use. So in my case, I have chosen Netty. I could use any of these. For example, I could replace it by Jetty. It would work too. Just to demonstrate it, this is the benefit of the JAX-RS framework and the benefit of the Jersey framework. You don't have to modify your code if you want to replace parts of the implementation. And here it's saying hello world, so you can choose any implementation you actually like. In a later episode, I will demonstrate you how to replace the JAX-RS implementation itself completely. I have just replaced Netty by Jetty here. I can also replace Jersey by, let's say, REST-EC. You might wonder why this line looks so scary. It's a bit more complex than you would expect it to be, and this is for a good reason. This is because you can reuse every part you create in this line. So, for example, we already are reusing our client if we want to do a second invocation. Let's do that. So what we reuse is just the complete client itself. We can reuse even more. We can reuse the target, for example. Let's do that. So we have to write a little bit more code. Oh, sorry. Certainly this will work. We could even reuse the invocation itself. And that also will work. So why do you want to do that? It makes the code look really, really scary. It still works, it still does the same. So what's the benefit of that? Actually, an invocation is a prepared call. So it knows everything you want to do, but not the actual parameters you send. So for example, you can prepare the repeated invocation of a get method with different dynamic parameters. This makes your code a lot more performant. It runs in higher speed because you just tell the client, do it again, do it again, do it again, and it just puts in the parameters needed. This performance benefit comes from two edges. The first edge is Java itself. Creating and dropping objects and doing garbage collection still in Java 14 times is a rather expensive operation. So if any possible, we will try to reuse objects, and this provides performance, particularly if you're using a framework which would do complex operations background like scanning class paths or scanning on disk or whatever. So we stop the framework from doing all these expensive things again and again and just keep the memory clean and just reuse an object. So this is the most performance benefit you can get if you have an object, reuse it. The other side where performance comes from is the HTTP 1.1 protocol. In HTTP 1.0, you are forced to create a TCP connection every time for every invocation. And opening a TCP connection is very time consuming. You send a lot of packets back and forth. So in HTTP 1.1, you were allowed to reuse the TCP connection, so you don't have to send all that packets around before you can use the connection. So this is what you're allowed to do when you keep your Java objects in memory, because you have created a connection already. So your JAX-RS client can reuse this open connection and simply send the request and receive the response without further ado. If you like this video, don't forget to give me a thumbs up. So far for today, have fun hacking, stay safe, and as always, party on!